Welcome to your own channel of Right Funda. Here is another interesting questions from electrostatics where the concept of rotation mechanics also to be used. Let's read the question. A point charge capital Q and mass small m is projected with some initial velocity v0 from a very far off point as shown. The sphere shown has a charge of minus q, the radius r, and the charge uniformly distributed over its entire volume. Throughout the process, the sphere stays stationary. It's given this, the sphere stays stationary. Find the V0 so that point charge strikes the sphere at 45-degree angle. Take gravity to be zero. Gravity to be neglected. Only electrostatic force to be considered. So the question is given that you will see this is our sphere, and this one sphere having charge capital Q and another charge having same Q moved from here, and it came and strikes this sphere 45-degree angle. So once you read the questions, now you start solving the problem. You can pause the video, and after you complete solving the problem or you tried solving the problem, then you can resume the video and see. So let's discuss this problem. What happened here? So if you see this is my sphere is there, okay, and there is a particle is there. So this is a particle, and this particle starts from here and goes like this. This is because of charge q is there here. So here charge q is there, and here also charge q has been distributed throughout this. Okay, and the distance separation between the radius of this r and the distance separation between these two, we can see this is given as the, from here to here you will see this distance is given as 2r in the question. And we'll see this, there is another, this point, if I draw the line of this point also, if I draw this from the center, I can draw this. Okay. So what is given is that this here to here the radius is r, and if I extend this line has been extended here, so I can set this extended line, this is the radius equal to r, and it strikes this at 45-degree angle. This angle is equal to 45 degree. The sphere surface is a surface is the, if this angle equal to 45 degree, surface man it will make 45 degrees. So with 45, this will be also 45-degree angle. So you see what is happening. This force is there, and one is positive charge and another is negative charge. One for positive charge is there, another is negative charge is there. Who is this? Sphere has a negative charge, minus charge. So this charge will be attracted by this. So as it is going, there will always there will be a force like this, and we know the electrostatic force and the field due to this. Field due to this at any point, we know the formula for the electric field due to a uniformly charged sphere at outside point. It is inverse square dependent now, and is always towards the center of this. So what we can do, we can suppose here the speed is given as the v0 speed, and by the time it reached here, the speed be equal to v, suppose. We don't know, v is unknown quantity. So what is the relation between this v and v0? The constraint relation between v and v0 can be calculated by applying conservation of angular momentum. Why conservation of angular momentum? Because the force, only force on the charge particle, only one force is acting, and it is passing to the center of this. So the net torque about this point is 0. There is a force is there, but that force is passing to this as a net torque at any moment about this point is 0. So I can apply conservation angular momentum for the whole system about this point. But the question is saying this is a rest. So I can apply conservation angular momentum for this particle also, because this is a rest here. So applying conservation of angular momentum for the system. So initial angular momentum Li, I will write is equal to Lf, final angular momentum, or when it is striking at this point. So initial momentum is equal to particle angular r cross p, so equal to 2r. I will write here. This will be equal to 2r into m v0. M is the mass of the particle, and this is 0 because the rest is equal to r m p into the angle between them, sine 45 degree, because r cross p is equal to r cross p initially, and again we're writing the r cross p initially for the particle, and sphere is a rest. That's why for the system we applied this one. So if I see this this r and this r get cancelled, this m and m get cancelled, and this is equal to I got 2 v naught is equal to v. This is not v. At this point, the velocity is v. So v into 1 by root 2. So I got v is equal to 2 root 2 v naught. So we got a relation between the velocity and the velocity at the initial velocity and the velocity when it will be striking, if it is striking 45-degree angle at the surface of the big sphere. So this is the one equation we obtain. What we can do, as it's electrostatic, this force, the electrostatic force is a central force. Electrostatic force is a central force, and we apply conservation of angular momentum, and this is also a conservative force. So as a conservative force, we can apply conservation of energy. So energy conservation of the potential energy plus kinetic energy initially should be equal to potential energy plus kinetic energy finally. This is the final state, or when it is striking as the initial state for whole system. But as you know, this is the rest, so its kinetic is no need to be considered. So we say the potential energy at initially it is very far point, so potential energy was 0 and kinetic energy was half m v naught square, and the sphere ka potential kinetic energy is equal to 0. Okay, I write this one is equal to potential at this point equal to minus k, or I can write potential to this k minus q by r, and at that point another charge q is placed. Is a potential electrostatic potential energy plus half m v square of the particle and 0 for the sphere. The whole system we applied. So from this we have a relation between v and v naught. So v and v naught can be we can substitute a v and v n. So we can get the half m v naught square is equal to minus k q square by r plus half m, and we have calculated v is equal to 2 root 2 v naught. So this is 2 root 2 v naught square. So this is equal to 8. So if I say this 8, this will be equal to 4 m v naught square. So if I take this set, so I got the 4 minus half into m into v naught square is equal to k q square by r. So let's see what the question is saying. Question is asking about find the v naught. You have to calculate the v naught has to be calculated. What's the initial velocity? So that will be there. So v naught I can write. So they equal to 3 by 2. And so this is my 3.5. 3.5 v naught square is equal to k q square by r, or in 7 by 2 I can take. So v naught square is equal to, this is this side is equal to 7 by 2, 2 by 7 k q square by mr, or I can calculate the value of v naught should be equal to q taken outside square root of 2 by 7 k by mr. This we got the velocity that should be there initially at a far up distance, and it is at a distance r from the surface of the big sphere, so that it will be striking the sphere that at an angle of 45 degree. This is where the k is equal to 1 by 4 pi epsilon naught. So we saw this question. So how we solve? Because we applied conservation energy from this point to this point and this point. We apply conservation angular momentum for the system about from this point and this point, and we got the constant relation v and v, and we found out that what should be the velocity here, so that it will be striking this at an angle 45 degree.